Got a video here for you. This is a 2010 A/B test for response question number 3. There's a graph here. Let's just check out this graph real quick. People per hour, so this is a rate and time. Okay, so people per hour, it's always positive, so the number of people is always increasing. Okay, let's see what's going on here. There's 700 people in line for a popular amusement park ride when the ride begins operation in the morning. So that's fundamental mistake of calculus, is to forget that there's an initial amount, right? Okay, because the area under a rate tells us the change in the number of people, but it's changing from this initial value. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate. So this is like people leaving the line. So we've seen this kind of problem before. Like there's a certain amount coming in and then there's a certain amount going out. The graph above shows the rate at which people arrive at the ride throughout the day. Time is measured in hours from the time the ride begins operation. All right, how many people arrive at the ride between time 0 and time 3? Well, you want to know how many people? This is the rate of change of people, so if you want to know the change in number of people, you do the integral. So for part A, how many people at the ride arrive at the ride? That is 0, the area from 0 to 3 of this rate. I don't have to add, they're not asking how many people are in the ride at time 3, or in the line rather. Then I'd have to add the 700. This is just asking how many people arrive, not how many were already there, or how many total. So just need to find the area here. So however you want to do that, you can carve that up into different shapes, whatever. I'm just going to notice here that each one of these boxes is 1 by 200, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 whole boxes, and then if I took that little piece and put it there, that's 15, and then that's 16, because I could just put that on there. So you can do triangles and all that, but it all adds up to 16 of those boxes. So 16 times 200, which is 3,200 people arrive in the line between 0 and 3. Part B, is the number of people waiting in line to get on the ride increasing or decreasing between time 2 and time 3? All right, so the number of people waiting in the line is going to, whether that's increasing or decreasing, depends on two things. It depends on the rate that they're showing up and the rate that they're coming out. Remember that people are coming out of the line at 800 people per hour, right? And between time 2 and time 3, right here, the rate is greater than 800, right? 1200 and then down to 800. So from time equals 2 to 3, R of t is greater than 800. So number of people in line is increasing because the rate of people going into the line is bigger than the rate of the people coming out of the line. Okay? Part C, at what time t is the line for the ride the longest? And then how many people are in line at that time? Okay, so if we're going to figure that out, there's a couple ways you can do that. I think what I would like to do is actually just make a function using an integral and my brain that shows us how many people in the line. So the number of people in line at time t is equal to, there were 700 people to start. The change in the number of people coming into the line is the integral from 0 to time t, whatever time you want to know, of the r of t, minus, oh, and this is that thing, since I used a t here, really I should use an x here. I don't think that you get busted for that on the AP test, but only because I used a different letter. So that's all that means. Just not supposed to use the same letter to mean two different things. And then the people coming out of the line, there's 800 of them per hour. Okay, so that is a function that is the number of people in line. Now, of course, we only have this function in graph form. So see what we can do with this. If you want to know at what time is the number of people at a maximum, I'm going to find p prime of t, right? And then I'm going to set it equal to 0. So the derivative of this constant is 0. The derivative of an integral, those two operations cancel each other out. Fundamental theorem. So that just gives me r of t dt. I can go back to t's now because I don't have two different places where I'm using that. And then minus 800. I'm going to set that equal to 0. I don't know why I put a dt there. That does not belong there. So what this is telling me, and we can think about this, this should make sense to us, that when the rate is equal to 800, that's when the rate of people coming into the line is 800, then that's when we're going to have a maximum, right? So right there. And that should make sense because as soon as we pass that point where the rate is now lower than 800 for people coming in, they're still going out at 800 per hour, so that means the total number of people in the line is going to be going down. If the rate is more than 800, then the line's going to be getting longer because they're only coming out at a rate that's slower than this. And here, the rate that they're going out is now bigger. So that's the 800 line. So max at time is equal to, when did that happen? At time 3? At time 3 hours. And that's because p prime of t goes from positive to negative. Okay, they wanted to actually know how many people, right? So I just need to plug 3 into my people equation. So that's 700, plugging it in here, plus the area from 0 to 3, which I think we already found, didn't we? Part A. And plus, minus 800 times 3. So that's 700 plus 3,200 minus 2,400 is 1,500 people. All right. This is what the fundamental theorem of calculus looks and feels like in this kind of problem. Write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. Okay, so if we want to find when there's no longer a ride, I think we kind of did it already in part C, didn't we? If we have this integral expression here, we just need to set that equal to 0, so the number of people equals 0. So that would be no people in line. Sure, just set this equal to 0. That's it. So I guess it was possible to do this one if you just realized, oh, this thing about the rates, you could have done part C without writing this equation here. So once we have that, that made part D very easy.